You know, our great freshwater lakes are, without a doubt, some of the most vital resources we have on the entire planet. But they're facing this growing, really toxic threat. It's been a tough battle to fight, but it looks like a new hero is emerging, not from a comic book, but from the world of engineering.
So what is this toxic green tide we're talking about? Let's dive right into the problem. It all starts with this phenomenon that's as dangerous as it is widespread, especially in places like the Great Lakes, which, provide drinking water for tens of millions of people.
Okay, take a look at this. This is a satellite image of Lake Erie. And from way up here in space, it almost looks like some kind of abstract painting, right? These incredible swirls of green in the water. But here's the thing, this is not art. This is what's called a harmful algae bloom, or an HAB, and it's a massive danger hiding in plain sight.
So what you're really seeing is just an out-of-control growth of algae. But the real problem, the thing that makes it so dangerous, is what it produces. It's a nasty toxin called microcystin. And that is the key here. That toxin is what turns these beautiful green slicks into a serious hazard.
And when I say hazard, I mean it. The health effects are severe. We're not talking about a minor irritation. As you can see, microcystin can cause serious liver damage, numbness, vomiting. It's a direct threat to literally everyone. Humans, our pets, livestock, any wildlife that depends on that water.
So, where do these things even come from? Well, it's kind of like a perfect storm of conditions. You get all these nutrients from fertilized farmland running off into the water. Then you combine that with calm winds and just the right amount of rain, and boom, you've got the perfect recipe for these toxic blooms to just explode across the surface.
Okay, so if we know the cause, why is this still such a huge problem? Well, to really get that, we need to take a look at the current, kinda old-school methods we're using to fight back.
And here's the bottom line. Our traditional approach is just not up to the task. It's incredibly slow, it costs an absolute fortune, and it's pretty much limited to when people are on the clock. You just can't effectively monitor a massive lake from 9 to 5.
And this table just lays out the challenge perfectly. I mean, look at these limitations. Boats, they've got a max range of about 30 miles, and they can only work during the day. Submarines are an option, sure, but they can cost $500,000 a pop, and then there's the people cost. Initiatives to monitor the water run into the hundreds of millions. It's an unsustainable way to fight this battle.
But this is where things get interesting. This is where a new idea comes in. Some engineers at the University of Windsor realized that, to fight a modern problem, you need a modern tool. And what they came up with is a really clever single-rotor solution.
And here it is. This is the Single-Rotor Unmanned Aerial Vehicle, or SRUAV. Now, it might not look like the drones you're used to seeing on YouTube, and that's completely on purpose. This is a custom-built machine, designed from the ground up for one very specific, very important job.
So why this kind of unusual design? This comparison really shows the genius of it. You see, a typical quadcopter, on the left, it needs 4 expensive motors. That just drains power and adds weight. But this SRUAV, on the right, it just uses 1. That makes it lighter, way more power efficient, and get this, it's strong enough to carry more payload than its own weight. It's just elegant, efficient engineering.
So you're probably wondering, how does it stay stable with just 1 motor? Well, it uses a really clever trick called a coaxial rotor. That means you've got 2 propellers stacked on top of each other, spinning in opposite directions. This completely cancels out the rotational force, the torque, which means the drone doesn't just spin itself in circles. It just stays put, incredibly stable.
And how does it move around? Well, instead of changing the speed of different propellers, the whole rotor assembly physically tilts on a ball and socket joint. You can see it right here, pitching forward. It's a simple, really robust mechanism that lets it fly in any direction it needs to go.
Okay, so we've got this cleverly designed drone. How does it actually do its job? Because it's not just about the hardware, it's about the smart, modular mission it's designed to fly.
The whole process is brilliantly simple. It's just 2 steps. First, the drone flies out to detect. It uses a special sensor to look for chlorophyll A, which is a total dead giveaway for algae. If it gets a positive hit, it moves to step 2, confirm. It'll either snap a high-res photo or even collect a physical water sample. Detect, then confirm. Simple as that.
And this is what makes it so versatile. The drone doesn't have to carry every single tool at once. It uses a modular payload system. So for a detection mission, it clicks in one set of tools. For a confirmation mission, it swaps that out for a sample collector. It's basically like a tool belt. It only carries exactly what it needs for the job at hand. So smart.
So, of course, the big question is the price tag. And here's the kicker. The bill of materials for one of these prototypes comes out to just under 660 Canadian dollars. Look at that number. Now, think back to that $500,000 submarine. This isn't just a better tool. It's a radically more accessible and scalable one. It's a game changer. But the real power of this technology isn't just in a single drone. The true potential is unlocked when you start to think bigger, when you think about how one drone becomes a fleet, an autonomous army standing guard over an entire lake.
The big vision here is to create a constellation of these drones that all work together in a coordinated swarm, right? So just like satellites in orbit, they would communicate and collaborate to cover a huge area far more effectively than any single unit ever could on its own.
And the logistics sound like something out of science fiction, but they're entirely practical. You basically divide a huge lake into a grid. You assign one drone to each square. They patrol their zones. And here's the cool part. If one drone finds its area is clear, it can be automatically redeployed to go help out in another section where a bloom might be forming. It's intelligent, decentralized teamwork.
And how many would it actually take? Well, the researchers estimate that just 107 of these drones could scan the entire 1,286-kilometer shoreline of Lake Erie in a single pass. A single pass! That is a task that is just physically impossible for the old guard of boats and people.
And this is the brain that guides the whole swarm. An AI analyzes satellite images, like the one on the left, to find the algae hotspots. And the result is the image on the right, with all the problem areas highlighted in red. This tells the drones exactly where to go, focusing their efforts where they're needed the most. It's like giving them a treasure map to the problem.
Now, don't just take my word for it. The researchers behind the project, they conclude with this, stating that this whole approach, an autonomous swarm of single-rotor drones, may be the ideal solution to fighting these harmful algae blooms.
You know, it all leads to this really powerful final thought. We started by looking at a single lake, but the potential here is obviously global. So the question we're really left with is this: could autonomous drone swarms become the tireless, ever-watchful guardians for all of our planet's most vital water resources?